Hi everybody, in this video I'm going to cover a few topics about logic and reasoning, and we're going to do these few questions that I have circled here. This, by the way, I want to note is courtesy of Springboard Digital Online, and let's go ahead and begin. So with the first question, we have a two-column proof, and this is called an algebraic proof because we use properties of equality related to algebra, and some on the right side are filled out, some on the left side are filled out, but there are also blanks on both the left and right sides. So with that in mind, let's go ahead and jump right in. We have in the first line what's called a given equation, and when it says given, all that means is that you go back over here where it says given and you grab the equation that you have, which is this over here. Now all you have to do is drop it in on the blank side. So 2x over 4 is equal to, and that would be 5x plus 8 all over 2. And that would be your given equation. Now that's the easiest step of all because all you have to do is grab what's already given to you and simply say this was free, it was given. Line 2, all of a sudden our equation changes and now we have this, and the reason is what we have to provide. So how did we go from something like this to something like this? Well, it turns out that our fraction in line 2 is not there, which means that what happened was both sides were multiplied by a 4. Okay, and this 4 over here on the left side divided out, and that gave us the 2x. And on the right side, the 4 and the 2 divided out and gave us just a 2 on the outside. And so our fraction is gone. So because we have to multiply both sides by a 4 in order for this to happen, the reason is simply the multiplication property. So that's what I write, multiplication property. Line 3. Line 3, our statement is blank, but the reason is given, the distributive property. So that should be a big clue. The only place we can distribute is right over here. So if we take the 2 and multiply it inside, what we would get is 2x on the left and then 10x plus 16 on the right, and that is the distributive property. Line 4. Now, line 4 and line 3 look very different, which means something had to have been done to make this change. We need to provide the reason for this change, and there is one way to look at this, and that is that the 2x had to have been relocated to the right side in order for there now to be nothing left on the left side. And in order to do this, you would have to subtract 2x. And so the reason we provide is the subtraction property. Okay, now going from line 4 to line 5, the subtraction property is our reason, and it's a big clue about what we need to write over here in this blank space. Now there are two ways that we can fill this in. We could either subtract 8x to both sides, or we could subtract the 16 to both sides. And it really doesn't make a difference because in the end you will get the same answer. So I'm going to go ahead and move this 16 to the other side. And what I see is that I get negative 16 is equal to 8x. Now, it turns out that this actually works out very well, since in line 6, our variable is on the right side. As you can see over here, the variable is on the right side. So it does make sense to move the 16 rather than the 8x from step 4 to step 5. So, how did we get to step 6 from step 5? Well, we would have to divide both sides by 8, and so that would be the division property. So division property. Now, step 7 says symmetric property. The idea of symmetry is simply this, and I'm going to zoom over here and give you a quick rundown. If you have two things like A and they are equal to each other, A and B are equal to each other, what this means is that you could simply say, well then, B is simply equal to A, right? Forwards and backwards, you are saying the same thing in a slightly different way, but you're not changing what you are saying. So if I take that idea and bring it over here, from line 6, I can take this equality and I could simply flip it around. And I could say, well, if negative 2 is equal to x, then x is equal to negative 2. And that right there would be my symmetric property. Alright, so that's an algebraic proof. Let's go ahead and move on to this question right here, number 14. Given that the hypothesis of the following conditional statement is true, which statement must also be true? And the conditional statement is right over here. If Margot wears gloves or a scarf, then she wears a coat. Now, it's telling you that she could be wearing a scarf or gloves, but not necessarily both. But there's one that is definitely true. Regardless of which one of these two items she's wearing, she will wear a coat. And so therefore the answer can only be letter A. Margot is wearing a coat. Number 13. Dustin says that 8 times negative 1 equals 8 is a counterexample that shows that the following conditional statement is false. Is Dustin correct? Explain. And here is the statement. If two integers are multiplied, then the product is greater than both integers. Well, in order to see whether or not this is true, you have to first go back to Dustin's original statement and have a closer look. Now he's saying that 8 times 1 times negative 1 equals 8. However, we know from our experience that 8 times negative 1 is actually negative 8, not positive 8. And so this statement by Justin is by default a false statement. So our answer is false. Number 12. Given a false conditional statement, if a vehicle is built to fly, then it is an airplane. Write a counterexample. A counterexample is simply one example that demonstrates that the conditional statement is not true in all conditions. So if you're saying that if a vehicle is built to fly, then it's an airplane, then you have to come up with an example of something that is built to fly but is not an airplane. And one example of that could be a helicopter. So the counterexample would be a helicopter. And because we're able to come up with one counterexample, that means that the original statement, which is a vehicle built to fly is an airplane, is false. And you already knew that because it said so in the beginning. False conditional. And even though it's not circled, we will do number 11. State the hypothesis and the conclusion of this conditional statement. This is a good review of what a conditional statement is and the components of it. So it says, if the temperature drops below 65 degrees Fahrenheit, then the swimming pool closes. The hypothesis is always the beginning part, the if part. So that would be from here to there. If the temperature drops below 65 degrees, that is your hypothesis. The last part, the then part, that's always your conclusion. Then the swimming pool closes would be your conclusion. So hypothesis and conclusion. Thanks for watching.